Okay, maybe one way to think about what a lattice of light emitting diodes could do. If you're imagining this ensemble and just a wire frame, CAD wire frame, so there's no blockages, no shadowing effect, and we'll just keep it a simplified context. If it's sending out a points out distribution of what's going on around it in that block, then that block can be a reference, a computational map. And so how it transmits that to another object, one way to think about it is QR logic. When you're looking at an image to take with your phone, is just a frame effect. And so that QR could be dynamically changing. It could be constantly updating with enough of a change to justify the amount of blocks getting changed. One of the critical elements is keeping it visible and readable. And then the next component is to see how much throughput might be able to be sent through that interconnect. And so that's what gets a person thinking about light emitting diodes. In this case, SK6812 light emitting diode in this mini format, a very small unit, and it has 4 wires going into it, giving the range of RGB, and so it can have a balanced output. And by using the field of color included into this QR landscape, then you get not only the linkage of how many pixels can couple with clarity of signal vision, thoroughfare, kind of a tunneling effect of what could be sent in transit in this light broadcast from one unit to the from one to the next. It can also be, a depth map of what's going on. If just the surface is lit, then distributions of light can describe the depth of data. And so I guess it's probably worth it to try to fluid state through a couple of these different dynamics, whether or not you're thinking of it as putting an entire map file in one dimensional block. And so the map itself warps perspective based off of the width, height, and depth of the map inside that volume, where some object in there has an inherent change to the speed of light because of the size of the container. That is the dimensional coupling of light lag and explaining things in kind of a nested thoroughfare. So there should be an easier way to do this. And so the QR logic, starting with that kind of, a signal timing. What's been interesting is studying OFDM, where a broadcast has change logic, and just in changing within a frequency, we can start with just an XY plane, and it sends out a signal, a uniform line, and the increase of pitch or the fall off ends up being the signaling media in a complexifying, to each RGB signal of warp. And one of the things that's interesting of drafting, what I learned about in drafting, is if there's an expectation for when all of these LEDs might flash this extra bright tick of signal, when there's those moments of that kind of balance truing, then that helps the entire system recompute the local warping of gravitational's influence on the characteristics of what image was sent through space-time, because in those moments you get the ability to imagine, okay, well, that meant that this was the exact depth of that node in reference to this other node. And so the truing characteristic ends up making that mathematics possible. And that ends up making the image clarifiable, where you have these mechanisms where the signals are trying to measure what's going on around it and trying to create a map of what's going on around it and creating a temporal reference anchor. And in doing so, then it gets the best average set to use in recognition of the amount of noise that it's hearing, or the waves passing through it in just the normal behaviors of space-time inside the actual signal sets of what happens when you turn the gain all the way up and try to find all the right signals in a otherwise noisy environment. Uh, and so now maybe I can summarize this in writing.